This video will discuss question 40. For the ADC in figure 7, please assume that the counter is a 12-bit counter. The duration of charge time interval T1 corresponds to 4096 clock pulses. The clock frequency is 10 MHz, the reference voltage is -2.56 and all elements are ideal. For which range of the analog input voltage VA is this ADC applicable? And then we get 8 possible ranges for VA. We should again look at the equation that we derived in question 37 for the number of discharge clock cycles. That is negative VA over Vref times the clock frequency and the fixed interval of phase 1. This fixed interval is by definition as long as the maximum number of clock cycles that we can have to count. So that's the maximum number that we can count with this ADC times the clock period, or in other words, the maximum number that we can count over the clock frequency. So if we substitute this back into the equation, that'll give us a definition that is independent of the clock frequency, but is dependent on the maximum number that we can count with this ADC. And then we should note that to reach the full-scale output, and this, or the number of discharge clock cycles, should be equal to the maximum number that we can count with this ADC. And that'll give us that mx is equal to negative VA over Vref times mx. We can divide both sides by mx, and that means that the input voltage for a full-scale output will be negative Vref. And if we substitute in this that Vref is given as negative 2.56, to get the full-scale output we need to have an input voltage of 2.56 volts. So that would be the upper limit of our range. Then we also need a lower limit of our range. That lower limit can now be found again by looking closely at the equation above. We can express any number of discharge cycles from 0 to the maximum number of counts. If our input voltage is 0, that would mean that our number of discharge cycles would also be 0. And that implies that the range for which this ADC works is 0 to 2.56 volts.